Now let's talk about quadratic functions. The general form of any quadratic function is f of x is equal to ax squared plus bx plus c. What we have to know about quadratic functions, first, we need to know the shape of the curve. The second thing that we have to know is the y-intercept. The third thing that we have to know is the x-intercepts, which we call them the roots. The fourth thing we have to know is the vertex. And the fifth thing we have to know is the equation of the axis of symmetry. Let's start now by having the first point, which is the shape of the curve. The shape of the curve, either we have a parabola which is concaved up, or we have a parabola which is concaved down. For the first case, the coefficient of x squared is positive. So when I find x squared to having a positive coefficient, then the shape would be concaved up. So the value of a in here is greater than 0. The second case, the value of a is negative, so it is less than 0. So I can understand if the coefficient of x squared is negative, then it is a concave down shape. The second thing we have to know is the y-intercept. The y-intercept is simply where the curve crosses the y-axis. If I want to draw an axis, I have my axis this way. The curve would be, if I have this curve, then the y-intercept is where the curve crosses the y-axis at this point. At this point, I know that the x coordinate is equal to 0. So the y-intercept is simply when x equal to 0. The third point that we have to know is the x-intercepts or the roots. Or I can call them the roots. The roots of the curve are this is my curve. The roots are where the curve crosses the x-axis. These are the roots. So I call the intersection on the x-axis to be the roots of the curve. The roots occur when the value of y or the value of the function is 0. So now we knew the shape, the y-intercept, and the roots. The third thing that we have to know is or the fourth thing now is the vertex. The vertex simply is the minimum or the maximum point of the curve. Is the minimum or the maximum point of the curve. The x-coordinate of the vertex is equal to minus b over 2a, or the x-coordinate of the vertex, I can find it by adding the roots and dividing by 2, taking the average of the roots. So it's root 1 plus root 2 over 2. After finding the x-coordinate of the vertex, if I want to find the y-coordinate to have the coordinates of the point of the vertex in x and y, I substitute simply the x-coordinate of the vertex in the original equation. The fifth thing that we have to know is the axis of symmetry. The axis of symmetry has an equation. Let's have an axis. Let's say I have my curve to be this way. The axis of symmetry is the equation of the line that cuts the shape in half. This is the axis of symmetry. The equation of the axis of symmetry, simply x equal to the x-coordinate of vertex is the same as the x-coordinate of the vertex. So the equation of the axis of symmetry is either equal minus b over 2a or equal to root 1 plus root 2 over 2. We have to understand that the shape is always symmetrical around this axis of symmetry. So the distance from this point to this point is the same as the distance from this point to this point. The axis of symmetry always cuts the shape in half. Now, after knowing all of these information, let's have an example. The example says a farmer wishes to fence off the maximum area possible to make a rectangular field. A maximum area possible, it means I have to find out the vertex. She has 150 meters of fencing, so the perimeter of the fencing is 150 meters. One side of the land borders a canal. We need to find the maximum area of the field. So in my shape, I have a canal. This is the width and this is the length. And the total length of the fencing is 150 meters. So now, let's form an equation for the area of the rectangle. I have the width, which is, let's call it W, and have the length, let's call it L. So now the area of the rectangle is simply equal to the length times the width. Now I have three unknowns: the area, the length, and the width. On the right hand side, I have two unknowns. It's not possible for me to find the maximum area because I want the right hand side to have only one unknown or one variable. So I need to form another equation using the given, which is the 150 meters. The 150 meters is the length of fencing having two widths and one length. So I have another equation. I have 2W plus L is equal to 150. Let's make L the subject. I'll having L equal to 150 minus 2W. After that, I take this value of L and I substitute it in the area equation, in this equation. So I'll be having the area to be equal to 150 minus 2W times W. Let's just expand it. This will be equal to 150 W minus 2W squared. And now I can see that this is a quadratic function. In order to find the maximum of this quadratic function, I need to find the coordinates of the vertex. I can just use my graphical display calculator to solve this equation. Since the area is 150W minus 2W squared, I go to my graphical display calculator, I go to menu, and I go to graph. Let's delete first. I have to graph my function, which is 150x minus 2x squared. So it's 150x minus 2x squared. And I draw. We can't see the function properly. Why is that? Because I have to change the V window. So I go to Shift, V window. The X minimum value, the X here represents the width. I can't have a width in negative. So I add the width to be 0. The maximum I can make it 50. The Y in our case represents the area. Since it's the area in terms of W, so the Y is the area. Also, the area can't be negative. And I can make it 1000. Let's see if I can see the shape properly now. And I go to draw. Still, I can't see it. I want to fix my parameters. Let's make the X maximum to be 100 and the Y maximum to be 3000. And I draw. And by this, I can see my shape properly. So now this is my curve. In order to find the maximum area, I want to find the Y coordinate of the vertex. So I go to Shift, G solve, and I press on F2, which is the max. The maximum point, it gives me that the X value of the maximum point is 37.5. Which means this is the width that will give me the maximum area. And the maximum area value is simply the value of Y, which is 2812.5. So rounded to 3 significant figures, the maximum area is the value of Y of the vertex, which is 2812. 10. So the maximum area is simply equal to 2,810 meters squared. And by this, I could find the maximum area by using our graphical display calculator to sketch the quadratic function that we formed.